Okay guys, this video is on graphing absolute value functions. We've been doing this on and off for a few weeks now, or a few months, but I can't emphasize how important it is to get good at graphing in general. All kinds of functions. But anyways, let's get started here. So here we have a typical absolute value function. Follow the gold. Notice right here we have an absolute value function, and let's just get to the point of graphing it. First thing we're going to do is make a table. Second thing we're going to do is we're going to look right inside the absolute value and ask ourselves, what makes it 0? Does everyone agree -1? -1 plus 1 would be 0, right? See, whatever makes it 0, guys, is going to be where the vertex is. So notice in the middle of my table I put -1. Now to get a really good graph, I'm just going to count up and down 2 numbers. Notice how I kept them in order: -3, -2, -1, 0, and 1. Always keep in order. You could have it in reverse order, but just make sure they're in order. Now, let's go ahead and fill in our numbers. So we'll start with a -3 here. Have to remember these are absolute values. Okay, so absolute value, guys, we do first just like a parentheses. -3 plus 1 is -2, but the absolute value makes it a +2. We're going to times that by 2. We're going to minus 3. 4 minus 3 is 1. Now, if you understand symmetry, guys, 1 is also going to be 1 as well. Okay, now let's go to -2. Let's plug that in. -2 plus 1, I do first. It's in the absolute value, which is -1. But the absolute value of -1, guys, is 1 times 2 minus 3. 2 minus 3 is -1. And 0 is going to be -1 as well because of symmetry. Now the number -1 that made it 0, guys, is our vertex. Let's go ahead and plug that in just so you can see the math, even though it may not necessarily be necessary. But notice how I get a 0 here, and the absolute value is 0, and when I times that by 2, I still get 0. Minus 3 is -3. Now guys, all I have to do is graph it. -3 is 1. -2, -1, -1, -3, 0, -1, and 1, 1 is right there. And I can't emphasize enough that you will always get a V shape when you're doing absolute values. You always will get a V shape. Now, what I'm going to do next, pause the video, by the way, if you need to. Now what I'm going to do next, guys, is graph the same function but in a different way. Alright? Now before I do this, I want to emphasize, guys, it's very important that you learn to make a table and fill it out for many reasons, but I'm going to require it in my class, okay? But I just want to show you again how the transformation or shifting works. So if we look at the same number 4 again, here is a quicker way of graphing it. Follow the gold. Again, I noticed right in there -1 would make it 0. And therefore -1, -3, see what I just did there? That's going to be my vertex. I know -1, which makes it 0, with that minus 3 at the end, is going to be my vertex. So simply all I need to do is go -1, -3. Okay? Notice that's the same thing I got here. Right there, right? And from here, if you agree that we know y equals mx plus b for linear equations, we should understand that that right there is basically a slope value. And so with the vertex, all I need to do, watch this in red, is I'm just going to count up 2 over 1 for slope 2. There's my next point. Do it again. Up 2 over 1. Right there is my next point. So as you can see, I got the same right side as I have here. Now what about the left side? Well, notice the left side, guys, is symmetrical to the right side. So all I have to do then, if you follow the, let me just erase the red here temporarily. If you follow the green, guys, I'm just going to go up 2 again, but then backwards 1 to get the opposite point. Again, these points here are symmetrical with each other, okay? And then I'm going to do it one more time. Up 2 over 1, backwards over here. And there is the left side of my absolute value. Please remember, absolute values always have the V shape. Okay, let's do one more. So guys, this one, we'll try to go a little bit faster here. Let's make a table. What makes it 0 in there is positive 4. Again, that's going to end up being my vertex, okay? I'm just going to count up a couple numbers, count down a couple numbers. Let's fill in our table. Let's start with 6. 6 minus 4 is 2. The absolute value of 2 right here, guys, is still 2 times the negative 3 plus 1. Well, that's negative 6 plus 1 is negative 5. By symmetry, 2 is also negative 5. Let's do the 5. Five minus 4 is 1. Absolute value of 1 is still 1 times negative 3 plus 1. That's going to be negative 3 plus 1, negative 2 there. 3 is also going to be negative 2. Finally, the vertex, even though we probably don't have to do it. Negative 3, absolute value. 4 minus 4, right, plus 1. Notice I get a 0. Times with negative 3 is still 0. Plus 1 is 1. And so now it's just a matter of graphing it. 6, negative 5. 5, negative 2. 4, 1. 3, negative 2. And 2, negative 5. Here is my V shape. Why is it going down or opening down? Because of the negative. Okay, try to remember a negative will flip an absolute value over. Okay, pause the video if you need to. Now, let's do it again, guys, but the quicker way. Does everyone agree? What makes that 0 in there is 4. That means 4, 1 is my vertex. So I just go to 4, 1. Notice my slope in front right there in purple, guys. That's basically my slope is negative 3. So from my vertex, I would just simply go down 3 over 1, because that would be a slope of negative 3. One more time, 1, 2, 3 over 1. There's the right side. The left side is symmetrical. We're going to do the same thing. Down 3, but this time reverse 1. Right there, down 3, reverse 1. So we can get the other side. And as you can see, this graph does match this graph exactly. And guys, that is how you graph absolute values. Until next time, bye.